The topic of this video is solving rational expressions equations. Alright, let's solve this problem. Solve the equation shown here. Let's go through the 5 steps. Step 1 is to determine what the answer cannot be. Well, we're not allowed to have 0 in a denominator, so x minus 4 is not allowed to be 0, and x minus 4 is not allowed to be 0. These are the same, I don't have to write it twice. Solving, I get x is not allowed to be 4. So I'm going to put that up here in the upper right-hand corner just as a reminder. X is not allowed to be 4 for this problem. Okay, steps 2, 3, and 4 is where I find out what the answer might be. And the first step in doing that is to make all of my fractions have the same denominator. So I'll rewrite the first fraction just the way it is. I'll rewrite the second as 4 over 1. And I'll rewrite the third just the way it is. So as you can see, this denominator is not like the other two. I need to make them all the same. So I will multiply at the bottom by x minus 4. I will also multiply at the top by x minus 4. So now I can see that my least common denominator is x minus 4. And if you're bothered by this 1, if you'd like, you can put times 1 here and times 1 here. Multiplying 1 doesn't change anything, so that's up to you if you want to do that. Okay, our next line, we're going to multiply our numerators. 1 times x is just x, and the denominator is the LCD, plus 4 distributed to the x minus 4 would make 4x minus 16, and the denominator is the LCD. 4 times 1 is 4, and the denominator is the LCD. Now, multiply both sides by the LCD. Well, this LCD is going to cancel with this one. They both turn into a 1. This is going to distribute to both fractions and therefore cancel both of these, leaving me only with my numerators. So now I'm going to have x plus 4x minus 16 equals 4. Combine like terms, 5x minus 16 equals 4. Add 16 to both sides, 5x equals 20. Divide by 5 on both sides. X might equal 4. Remember, in steps 2, 3, and 4, we're finding what the answer might be. The first thing you should compare to is the restricted value you found in part 1. Well, in part 1, we found that x cannot be 4. Therefore, we have to throw this away. And if the only potential solution you have gets thrown away, that leaves you with no answers, so the final answer to this equation is no solution. This illustrates the importance of always going through all 5 steps for every single problem, because you never know when a possible solution will actually not be allowed. You have to compare it to what you found in step 1 and what you might find in step 5.